Have you ever wondered how machines can find hidden patterns in data without any guidance or feedback? Welcome to the intriguing mystery of unsupervised learning. It's a type of machine learning that's like a detective, working alone on a case with no leads. It trains models on unlabeled data, meaning there's no predefined answer key for the machine to follow. It's all about discovery, like an adventurer exploring uncharted territories. The goal is to uncover hidden patterns or intrinsic structures in the data. Imagine trying to solve a puzzle without the picture on the box as a guide. That's what unsupervised learning does. It sifts through the data, looking for relationships, structures, and patterns that aren't immediately obvious. It's a fascinating field, full of potential for innovation and discovery. So, in essence, unsupervised learning is like a detective sifting through clues to uncover hidden truths in the data. Now that we know what unsupervised learning is, how does it achieve this feat of finding hidden patterns? Well, let's delve right in. Unsupervised learning employs a variety of ingenious techniques. One of these is clustering. Just like a beekeeper groups bees into hives, clustering algorithms group similar data points together. Picture a constellation of data points spread out in a multidimensional space. Clustering gathers the twinkling data stars into distinct galaxies based on their similarities. Quite a celestial spectacle, isn't it? But that's not all. We also have another powerful technique called dimensionality reduction. Now imagine you're an artist. You've got a palette full of vibrant colors, but your canvas is small. You can't use all the colors without creating a mess. So what do? You mix the colors to create new shades, reducing the number of colors, but still capturing the essence of your vision. That's exactly what dimensionality reduction does. It aims to reduce the number of input variables in the data set while retaining as much information as possible. It's like creating a minimalist masterpiece from a cacophony of colors. These techniques, clustering and dimensionality reduction, are the paintbrushes and chisels in the hands of unsupervised learning. They chisel away at the raw block of data, revealing the beautiful sculpture hidden within. These techniques are the tools that make unsupervised learning a reality, enabling it to uncover the hidden patterns in the data. Shall we see unsupervised learning in action? Picture this: we have a set of sample data. Let's use Python's sklearn library to execute the k-means clustering algorithm. Our dataset, represented as x in our code, is an array of number pairs. To apply k-means clustering, we first need to define the number of clusters. In this case, we're going for 2. Next, we fit the model to the data. This step is where the unsupervised learning happens. The model is looking at the data, seeing patterns we can't, and learning from it. It's like giving a child a box of unlabeled toys and watching them sort it out. Once the model is trained, it's time to get the cluster labels. These labels, accessible via the labels_attribute, tell us which cluster each data point belongs to. It's like our child now telling us, these are the cars and these are the dolls. Finally, we get the cluster centroids using the cluster attribute. These centroids are the central points in each cluster, serving as a kind of representative for the data points in that cluster. And there you have it. The k-means algorithm has clustered the data into 2 distinct groups, all without any guidance from us. It's quite remarkable, isn't it? This example perfectly illustrates how unsupervised learning can be used to uncover hidden structures in data, making it a powerful tool in machine learning. To wrap up, let's summarize what we've learned. Unsupervised learning is a unique type of machine learning where models are trained on unlabeled data, hunting for hidden patterns or intrinsic structures. Techniques like clustering, grouping similar data points together, and dimensionality reduction, which minimizes input variables while preserving information, are critical. Remember our Python example with the k-means clustering algorithm? That's unsupervised learning in action. Unsupervised learning, with its ability to uncover hidden patterns, is indeed a fascinating aspect of machine learning. The future of AI is exciting, isn't it?